Hey everybody, we are looking right now at the Topic 10 test review. All right, we're going to have answers for all of the questions from the Topic 10 test review. This will hopefully get you ready for the test, which is coming up very soon. And the idea here is just like all the other test reviews that we've done, okay? These questions that are on here are very similar to the ones that are going to be on the actual test itself. And if you know how to do these, you will have no trouble when you get to the actual test itself coming up. All right, so we're going to start off with problem number one, asking what is the value of x? Now, this right here, you can see it's a right triangle. We've got that little square down in the corner. Okay, what is the value of x? Well, this is asking a question that's basically from seventh grade math. Okay, it gave you the length of the two legs of the triangle. You are looking for the length of the hypotenuse, and it's a right triangle, so we know that we can use a Pythagorean theorem. A squared plus b squared equals c squared. Okay, so we plug in the numbers that we know. We know that the legs are 8 and 12, so that becomes 8 squared plus 12 squared. We know the hypotenuse is x, so that becomes x squared. After that, it's just a matter of simplifying and combining like terms. And then when you get down to right here, you got to take the square root. Okay, y'all have done this. Y'all have done this since middle school math, so I'm not too worried about it. But here's the part that's something new for us. Okay, we get it down to where we take the square root on both sides. This is the part that's new because we want to have this in exact radical form answer. We do not want a decimal approximation. And so what we do is we take that number 208 and we factor it as much as we possibly can. Okay, the easiest way to factor, just as a little tip, the easiest way to do this is going to be to try and divide by 2. And if that doesn't work, try and divide by 3. Okay, this one does divide by 2. It's 2 times 104. You can do 2 again, and you can keep going on down with twos as much as you can until you find something that doesn't work. Okay, this one is where it ends right here. Okay, we got all prime factors going across the bottom. So what we just did right here is we showed that 2 times 2 times 2 times 2 times 13, that's 208. Okay, but what we're concerned about, as y'all will remember, what we are worried about right now is the pairs. Okay, I see a pair of twos right there. I see another pair of twos right there. And I see a 13 that's right there by itself. Okay, what that tells us is that on the outside of our square root, we're going to have 1, 2 times another 2. Okay, because those are the pairs that we can pull out of the radical. So we're going to have 2 times 2 on the outside, which will be 4. And left inside the radical, we're going to have square root of 13. And that's what we got. X equals 4 times square root 13. All right, our next question was asking us to find the square root of 540. So we're going to do basically the same process as what we did in the second part of this problem. We're going to take 540 and we need to factor it down as much as we can. Well, that's 10 times 54. You can tell that's pretty clearly. We got a 0 at the end of that number. You can multiply it times 10. Well, 10 is 5 times 2, definitely. 54, if you don't know, you can just do 2 times 27. And that's 27. That's 3 times 9. 9 is 3 times 3. Okay, so we're going to do the same thing right here. We're going to look for pairs. So I see a pair of 3s right there. I see a pair of 2s highlighted there. And I see a 5 that's by itself and a 3 that doesn't match up with any other matching 3. So inside the radical, we're going to have a 5 and a 3 left by themselves. On the outside, we're going to have 2 times 3. So we've got 6 square root 15. There we go. This next one right here, what is the value of x? Okay, this is a callback to in the topic 10 notes when we talked about special right triangles. And this particular one is a 45, 45, 90 triangle. You can tell that just because that's what the angles are, 45 degrees and 45 degrees. Okay, there is a specific relationship between the length of the leg and the length of the hypotenuse on a 45, 45, 90 triangle. And that is this. First off, both of the legs are the same. So if this leg is 8, this leg is also 8. And the length of the hypotenuse is whatever that length is, whatever the leg is, times the square root of 2. So if the leg is 8, then x is going to be 8 square root 2. Our next problem is another special right triangle, and this is a 30, 60, 90 triangle. This would be something good to add to your cheat sheet, by the way, this relationship right here. The longer leg on a special right triangle is the short leg times square root of 3. So if we're looking at it that way, then that means the longer leg, 5, equals x times square root of 3, right? Well, we are not interested in x times square root of 3. We want x. That's what the question is asking for. What is the value of x? So we look at this and we say, what's happening right here? Well, x is being multiplied times square root of 3. X is being multiplied times some number. So what do? We divide by that number, and that'll give us x by itself. We divide by square root of 3, and that's how we get this answer right here. X equals 5 divided by square root of 3. Up next is where we start talking about trigonometry, and y'all know that's one of my favorite subjects to talk about, okay? So we've got cosine being asked about in this equation, and we know that cosine is the adjacent side divided by the hypotenuse. So remember, there's something very important that you might want to add to your cheat sheet is this little abbreviation right here, SOHCAHTOA. Okay, remember, some old hippie caught another hippie tripping on acid. Okay, and that tells us that sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. All right, that's what all of that means. That's why we keep writing this thing down right here. That's why we keep writing down SOHCAHTOA. Okay, so cosine is the adjacent over hypotenuse. We've got that written down right over here. So we look at this triangle, and we have to decide which leg of the triangle is the adjacent, which leg is the opposite. And what I'm looking at is that this side over here, the side BC, that is not touching the angle that we're dealing with. This theta down here that we're dealing with is not touching BC, so that would be the opposite side. The adjacent side is the one that's right directly next to our angle. It's the one that does touch our angle. So our adjacent side is going to be CA. The hypotenuse is always the side opposite of the right angle, so that's going to be BA. So we've got CA over AB as the adjacent over hypotenuse, CA over AB. Up next, we're looking at tangent. Y'all remember our SOHCAHTOA and what that always looks like? Okay, we've got it written down right here. Tangent equals the opposite over adjacent. That's what tripping on acid, the TOA, stands for right there. Tangent is opposite over adjacent. So we look at this angle up here now. We're dealing with the angle on the top left. The opposite side is the one that's not touching it right down here. DE is our opposite side. And the adjacent side is the leg that is touching, FD. So if we're going opposite over adjacent, that's going to be DE divided by FD. All right, here's where some of the problems start that are asking for a numerical input answer. Okay, so it's not just multiple choice anymore. You got to put something in for yourself. All right, so we're looking, what is the value of x? Okay, so when we look at this triangle, we've got one angle here. This is the one that we're going to be dealing with. Okay, you can go ahead and mark that off. That's the angle that we're going to be dealing with. And you can see that the two sides that we're going to be dealing with, one of them that's given right here, the 16, that's the hypotenuse. And this side x that we're looking for, that is the opposite. So if we are considering some old hippie caught another hippie tripping on acid, we know that in this problem we're going to be dealing with the opposite side and the hypotenuse. So where in all of this do we see the opposite and hypotenuse together? The answer is right here at the front. We see the opposite and hypotenuse together right there at the very beginning. So we know that this is going to be a sine problem. Okay, our equation is going to be sine. And here's the thing, when you're making these equations, when you're writing these equations, they always look pretty much the same. Okay, they're always basically the same thing. In this case, it's going to be sine of our angle, 40 degrees, equals the opposite side divided by the hypotenuse. So sine of 40 equals x, the opposite, over 16, the hypotenuse. Okay, On the right side of this equation, x is inside of a fraction, and we want it to no longer be inside of a fraction. We need x to be by itself. So what we're going to do is we're going to multiply times the denominator of this fraction. Okay? Anytime you have the variable inside of a fraction like that, we want to multiply times the denominator, and that'll give us the numerator completely by itself. So we multiply on both sides times 16. That gives us 16 times sine 40 on the left. We have x by itself. Now this right here, if you have one of the good calculators that you can, if you've got one of the good calculators that has all of the trig functions, you can type it in exactly like this. And if you are in degrees mode, that's going to give you a good answer. But if you don't have one of those nice calculators, what you can do is look on the chart and you can write down the fact that sine of 40 degrees is just equal to an approximate decimal number. You can look at that and you can see that sine of 40 degrees is just equal to, oh, hang on, where'd it go? You can see that it's equal to 0.6428. You can just multiply 16 times that, and either way you get this same answer, 10.3. Okay, the length of this side is 10.3. Up next, we're looking at this problem. Again, it's asking for x. It's asking us to find a missing side here, and we have to figure out what are we dealing with. Okay, so when I look at this angle down here, this is our given angle that we're working with. This side that's given to us is the adjacent side. We know because it's the leg of the triangle that's touching the angle, so that's the adjacent. This side over here is not the hypotenuse, but it's not touching our angle, so that must be the opposite. Okay, so we have to ask ourselves which trig function is giving us would we use for a problem dealing with the opposite side and the adjacent side, and that's going to be tangent. Okay, so we take tangent and we set up our equation the same way as always. Tangent of our angle equals the opposite over adjacent. So tan 23 equals x, the opposite, over 7, the adjacent. Again, this is just like the last problem. We need to get x by itself. We multiply times the denominator, and there we have x by itself. So this is something you can type in the calculator exactly as it is. 7 times tangent 23. In degrees mode, you will get a good answer from that. If you don't have one of those good calculators, you can just type in 7 times 0.4245. And either way, you're going to get this good answer. When you round to the nearest tenth, it actually ends up being just about 3. 3.0 is when you round to the nearest tenth right there. All right, this next problem is more of the same stuff, but you're going to see something different about our process here in a minute, okay? So this time we got to figure out again, we got to look at what's given to us, and we have to figure out which of the trig functions are we going to use. Okay, I can look at this and I can see that this is our angle. It gives us the adjacent side. We're looking for the hypotenuse. So when we look across this, we need a trig function that uses the adjacent and the hypotenuse. Well, I see that right here in the middle of our SOHCAHTOA. Adjacent and hypotenuse are together under cosine. So that's what we're going to use. We're set up a cosine equation. Cosine of our angle equals the adjacent over hypotenuse. So cosine 52 equals 8 over x. Now, just like before, our x is inside of a fraction, and we want it to not be inside of a fraction. So we multiply times the denominator, just like we did before. Okay, we multiply times x on both sides. Now, here's the question. On the left side of this equation, x is being multiplied. Okay, cosine of 52, that's just some number that you can find in the calculator. Okay, cosine of 52 is some decimal number, pretty close to 0.6. Okay, if you have x times a number, how do you get rid of that number? X is being multiplied, so we're going to divide it. Divide both sides by cosine of 52. That'll give you x by itself because all of that is all going to go away, right? You're multiplying and dividing at the same time. It cancels out. So we get x by itself equals 8 divided by cosine of 52, which is the same thing as 13. Again, when you round to the nearest tenth, it ends up being 13.0. All right. Come on now to our first word problem. It says that Mike is looking up the top of the building, top of Saginaw High School, at an angle of 18 degrees. He's 100 feet away from the base of the school. How tall is the building? Okay, so we've got a lovely picture of the situation already set up here on the slide. Okay, we've got a great diagram where we're looking up at an angle of 18 degrees. That's this one down here. That's our angle of elevation. It's 18 degrees above the flat ground. And that is 100 feet away from the base of the school. So this side of the triangle over here is 100 feet. It's asking how tall is the school? Okay, so what is this side of our triangle? So you can tell pretty clearly when you're looking at this that we're dealing with the opposite side is what we're looking for. We're given the adjacent side right here. Okay, so that's going to be a tangent problem. Tangent of our angle equals opposite over adjacent. It's that equation again, that equation that's set up the same way every time. Tangent 18 equals x over 100. We multiply times the denominator, just like we've always done. You punch that in the calculator exactly as it is, and we end up with 32.5. Okay, so that tells us that it is 32 and a half feet tall. Our next word problem. Okay, a lot of y'all did this word problem a little bit different and ended up with the wrong triangle. Okay, let's talk about it. Sue is about to ride a zip line. She is on top of the tower that's 62 feet tall. Okay, so our person starts off up here, 62 feet off the ground. She is looking down to the end of the zip line at an angle of 13 degrees. Okay, our key phrase right here is that she's looking down. A bunch of people tried to set up this problem where she was looking down and we had this angle as 13 degrees. Y'all, this angle is not it. Okay, that right there is incorrect. Okay, this triangle, the way it's already set up right here, that's what it's supposed to be. Okay, you got to think about this. When you're looking down, you're dealing with an angle of depression. Okay, an angle of depression is below straight horizontal. Okay, so if Sue is looking out straight horizontally from 62 feet up in the air, that's looking straight across this line. But she's looking down at an angle of 13 degrees. So that's how we end up working with this angle up here instead. Okay, that's the angle we're working with. That's 13 degrees. So when we look at this angle, our 62 feet is the opposite side. The length of the cable, the length of the zip line that we were looking for, that's going to be the hypotenuse of our triangle. So we've got the opposite and hypotenuse. According to SOHCAHTOA, that means we're going to be working with a sine equation. So sine of our angle equals the opposite over hypotenuse. Sine 13 equals 62 over x. And just like we've done so many times before, multiply times the denominator. X times sine 13 equals 62. Divide by this number. Okay, we know that x times sine 13, that is just x times a number. If this was x times 2, you know that you would just divide by 2 and get x by itself. Well, this is x times some decimal number. So if we divide by that number, whatever it is, that will give us x by itself when everything cancels out right there. This right here, this expression, 62 divided by sine 13, that is something you can type into the calculator as is. And that gives us an answer of 275.6. It tells us this zip line, 275.6 feet long. All right, so this is one that a lot of people have struggled on. says a triangle has side lengths of 4 inches, 8 inches, and 9 inches. How would you classify the triangle? So this was on the very back page of your Topic 10 notes. The last page that we did together on these notes said that you can classify triangles using Pythagorean theorem. Now we know the Pythagorean theorem. That says a squared plus b squared equals c squared. And that tells us about the side lengths if you're working on a right triangle. Okay, but if you're not working on a right triangle, then a squared plus b squared is not going to be equal. It's going to be either less than or greater than. And if c squared is less than a squared plus b squared, then that's going to be an acute triangle. If c squared is greater than a squared plus b squared, then it's going to be an obtuse triangle. So what we have to look at is figure out which of these sides is A, B, and C. And that's pretty easy to do. Your largest side is always going to be C. So we're going to compare C squared compared to A squared plus B squared and figure out what goes in the place of that question mark right there. All right. Doing the little quick math, 81 is 9 squared, 8 squared is 64, 4 squared is 16. We add all that up, and we're looking for the relationship between 81 and 80. Well, we know that 81 is greater than 80, right? That's common sense tells us that 81 is more than 80. But what that means is that c squared is greater than a squared plus b squared. So it must be an obtuse triangle. That's the answer we were looking for, is obtuse. All right, our last one, classify the triangle by sides and angles. Okay, so y'all remember from that section of notes that there are two different ways we can look at triangles. One of them is by the angle measures. One of them is by side lengths. Okay, so when I look at this, it tells us the triangle is not drawn to scale, and that's a good thing because when you're just looking at it, it looks like this angle down here and these two angles are the same, but they're not. This one is definitely more than these other two, and in fact, it is significantly more even than 90 degrees. So that tells us it's going to be an obtuse triangle. Okay, the other thing we look at is that these two side lengths, these two sides right here and right here, both have one tick mark on them. So that means those two sides that I highlighted are congruent to each other. So if you've got two sides that are congruent, that is an isosceles triangle. And if you've got one angle that's larger than 90, that's an obtuse. So those are the two things we would pick out, isosceles and obtuse. All right, if you have any questions as you're working through this, please let me know. We're getting ready to take this test very, very soon. So study up. And again, if you know how to do these problems, you should have no trouble when the actual test comes around. All right, so let me know if you're struggling, and we'll get you figured out, get it squared away. All right, y'all have a good one. That's all we got.